ontology-based data access. Today, I would like to explain the practical session about what are the projects are involved in this ontology-based data access applications. So far, I have covered what is introduction to ontology-based data access, foundational concepts, introduction to ontologies, introduction to data sources, and creating mappings, query transformation, and seventh and remaining topics today I would like to explain. How to implement ontology-based data access system, what are the advanced topics in advanced ontology-based data access, and what are the applications, tools, and techniques, and followed by the case studies and projects. So I think everybody knows ontology is a relationship between, and it is a formal representation of knowledge and a relationship between past data, that is existence data, past data, being data, and reality, and it is a formal representation of knowledge or information. Finally, we are developing a ontology-based data access. We are getting a unified view of heterogeneous data sources. Heterogeneous data sources is nothing but multiple data sources. One is flat files, one is SQL files, one more is MySQL files, DB2 files, and CSV files, etc. So being a technical student, you are asking the query to the ontology-based data access related particular health domain, particular NASA data, particular health related, particular you can call it as a traffic data, weather forecasting, etc. So these are the concepts I have explained already. Um, so in these ontology-based data sets, many industries like healthcare, manufacturing, and logistics and among, they are developing their own ontology and developing their own applications. So it is used to develop more intelligent and flexible access data uh, in the umbrella of artificial intelligence. So this is the hierarchy of ontology of data science. I have explained already. It starts with raw material data and ends with the ontology of data science. Ontology of data science. In between, we have a terms like information, database, DBMS, database system, data mart, data warehouse, data mining, big data, and the last buzzword in the industry, data science. So ontology of cyber security also I have explained. Cyber security ontology we are developing existence, being, and reality. That means past data, current data, and future data. So we need to use starts with computer and ends with cyber security. In between, the terminology called ontology, networking, operating system, program or software, hardware or servers, data center, computer networks, cloud computing, mobile security. Then why do we want to go for ontology used as an interface between users and data sources? So ontology is used as an interface between different users with different data sources, and we are developing a relation between past data, current data, and future data. That is called ontology. It provides a unified view of multiple data sources. Examples: SQL database, weather forecasting database, and traffic database, Sensex database, stock market database, multiple data heterogeneous data sets. It allows to query data using domain specific terms without needing to understand the underlying database schemas. So that's why we can see the ontology based data access in various domains like a healthcare domain and e-commerce domain, research and academia, supply chain management, environmental data management. I have explained already. Then what about major concepts of ontology-based data access? So what is ontology? Ontology is a formal representation of information or knowledge. That means we are developing interested information based on the terminology, based on the index terms, while maintaining the relationship between past data, current data, and future data. Then what is meant by mapping? Mapping is the creation of application between user and multiple data sources. What type of ontology we are developing in the conceptual view? Then what about query translations? With the help of a Spark QL and SQL, we are converting one form to another form. That is called a high-level queries. Then reasoning. Why we are developing this ontology based on the defined relationships and rules. We are developing reasoning so that we can get the very good accuracy of the particular applications. Data source. Data source where we are getting a huge volume of data from the system, server, data center. So we have multiple heterogeneous data centers like data sources like stock market exchange data, retail market, and as well as supermarket data, weather forecasting, healthcare data, education data. These are the various data sources are available. Even bank data. The goal of ontology-based data access is to provide a unified view between user and the multiple data sources. That is called a data source. And users and user queries. Users are end users, customers, and participants. What type of queries they are
Waste
asking
mailers.
related to particular
Oi!
domain. Then
Sir,
finally,
questions
data
అడగద్దా మిమ్మల్ని
visualization.
చెప్పకపోతే
What
అటెండెన్స్
type
ఆప్షన్
of
వేపిస్తా
graphs we are generating? Finally, manager or principal would like to see the results like a pie chart, bar chart, line chart, etc. Then what is meant by OBDA detailed process? You
నర్మదా
need to
ఏం
know the
చేస్తున్నావు
detailed process. Process means program under execution. Maybe lightweight process and heavyweight process. So that depends on what type of relationship you are developing a particular application. It is ontology based on ontology based data access related to healthcare, ontology based data access related to stock market exchange. That is called a web ontology language, OWL. Then mapping creation, creating a creation of mapping between a user and the data sources. And query transformation, we are conversion one form to another form with the help of a Spark QL and OB and SQL. And we are translating one form to another form. That is called query language for relational description framework. That is a query transformation. Data access, what are the methods are available in order to access the flat files, in order to access the audio files, video files, text files, or any other kind of files. Then the role of ontology. Ontology playing a vital role in order to develop a unified view of formal representation of the knowledge or application or information. So, in order to develop ontology, the ontology playing a vital role in order to develop high-level model. Model means simplified version of the reality. So, we have n number of data sources like relational databases, NoSQL databases, XML databases, etc. Mappings are key component of an OBDA system. They link the ontology high level concepts and relationships with the corresponding elements in the data sources, and we are using various mappings, one to one mapping, many to many mapping, or one to many, many to one, etc. Then query transformation and execution. Based on the query, SQL queries for relational databases, it can extract information, meaningful data by using a Spark QL, which is standard query language for RDF and ontologies. Then foundational concepts, we have a data access, I have explained already. Ontologies, I have explained. Semantic web technologies. So some of the semantic web technologies are critical to online, I mean ontology based data access, including like RDF, resource description framework. That is a standard model for data interchange on the web, and web ontology language, that is called defining and instantiating web-based ontologies. And third one is a Spark QL. It is a query language for resource description framework. Then fourth one is mappings. I have explained already mappings. It is converting into high-level queries over the ontology into low-level queries. Then query transformation and data integration. With data integration is nothing but multiple data sources are making unified view of formal representation of information. That is called data integration. Then, if you see the diagram, user would like to ask the queries and target ontology. There is a mapping between user and the source databases. by using SparkQL, Ontology, web language, R2R, ML, etc. Okay, web ontology language, OWL. Then introduction to data sources for ontology-based data access. I have explained already relational databases and non-relational databases. Based on the schema, based on the table, based on the relation, we are developing the tables. Collection of tables is called database. That is called relational databases. And there is no schema, there is no relation, there is no procedure, but we are developing a databases based on audio, video, text, graphics, animation data. That is called NoSQL databases. Then XML and JSON document, these are two types of stored data. Extension markup language and JSON formats, which are commonly used for exchanging data over the web. Then we can use web APIs and web services. We are using APIs is nothing but application programming interfaces. In Java, Python, we have various APIs and web services like XML, JSON, etc. Semantic web services, we are using resource description framework and ontology web language are used to store SparkQL endpoints can also be directly linked with the ontology. And data warehouse. Data warehouse is used to store multiple data sources in a system server or data center. File system and data lakes. It is also a special concept in ontology-based data access, how the file structure is organized in the server system data center. Then ontology-based data access consists of various creating mappings like identify the data sources, define the ontology, create the mappings, validate the mappings, and refine the mappings, maintain the mappings, etc. And the query transformation, it consists of various main steps like query formulation, query analysis, mapping, lookup, then a query rewriting transformation, and a query execution, result formatting. And how to implement. From this one, I am going to implement ontology-based data access on various applications. So define the ontology. Ontology is a relationship between old data, that is called legacy data, current data, and future data, and unified view of formal representation of information or meaningful data with the help of OWL and RDF. Then identify the data sources, what type of files we are handling. So whether you are handling relational databases, non-relational databases like XML files, CSV files, ERFF files, attribute relation file formats, flat files, audio files, video files, text files, etc. Create the mappings. So mappings define how data from the source should be interpreted according to the ontology by using SQL and XPath expression, and we are creating the mappings. Then implement the query transformation system. We are implementing with help of Spark QL to SQL translator. Test and refine the system. Eliminate the errors and finding the errors and eliminating the errors by using test and refine the system. Then user interface design. It is also one of the GUI, graphical user interface system, how easily user can interact with the system. Then what are the advanced topics in ontology-based data access? We have used scalability. Scalability is nothing but number of users are increasing, automatically data center also increases. That is called scalability. Suppose you are taking ontology-based data access related to healthcare. How many patients are there? How many hospitals are there? How many doctors are there? How you are mapping between patient and doctor, and various forms of data sources in different sources. That is called scalability. Expressive mapping. What type of designing you are using, and mapping languages and studying their computational properties. That is called expressive mappings. Handling of incomplete and uncertain data. So these are the issues we are discussing and advanced concepts in this handling of incomplete and uncertain data. And like you can use probabilities associated with the facts, etc. temporal and spatial data, like seasonal data and stock market data. That is example for a temporal and a spatial data. And machine learning and OBDA, this is the latest topic. We are using machine learning, artificial intelligence, deep learning in order to implement ontology-based data access, privacy and security. So privacy and security, wherever data is there, there is a security problem. In order to avoid the security, we are using security mechanisms in order to increase high security. Streaming data. Streaming is a flow of data between server to system, system to server, client to server, server to server. So that is called audio data, video data you are streaming from one system to another system. Debugging and validation, we are eliminating the errors. It is the process of eliminating
Pranika,
errors
ఏం చేస్తున్నావు?
in a code of ontology based healthcare data, usability and user interfaces. How we are using that particular model of you have developed ontology based data access of healthcare. Then finally, applications of ontology-based data access. I have explained already various applications like a healthcare domain. We are using ontology and scientific research. We are using ontology and enterprise information integration. We are using different types of kinds of data. We are using government and public administration wherever if efficiently access this data, aiding in policy making, planning and public services, etc. E-commerce is one of the application in order to use ontology here related to Amazon and Flipkart, and we are developing ontology related applications. Then semantic web, we are using semantic web more enabling more intelligent data retrieval from diverse and multiple sources of web sources.
సాహిత్య
Data
ఏం
warehousing
చేస్తున్నావురా?
and business intelligence. Data warehousing is used to store a huge volume of data in order to develop various web application. Education is also one of the application. Legal domain, it is also one of the application, and analyze legal information from various sources, facilitating legal research and practice. So applications of ontology-based data access, we have RDB, R2R ML engine, ontology, shackle constraints, etc. Then advantages of ontology-based data access, we have a semantic integration, that is one more advantage, data integration, abstraction, and interoperability, data quality and consistency, complex queries system, complex query support, preservation of native data, and ease of evolution and efficiency. Then what are the disadvantages of ontology based? Ontology and mapping criterion, that is a problem sometimes. Maintenance is a problem. Performance is a problem. Data quality is a problem. Then limitations of ontology languages, inflexibility of schema, and training, limited tool support, semantics, misinterpretation, etc. Then what are the tools?
Sir, your
There are
voice is
various.
not audible, sir. Sir, Srinivas, sir.
Hello, sir. My voice is audible. Hello, sir. Now my voice is audible, sir. One second. Hello, sir. My voice is audible. Shankar, sir. My voice is audible. Hello, sir.
Okay, sir, it's audible, sir. You
Yeah.
carry on, sir. You
So
carry
now,
on.
yeah, there are various tools like ONTAP. ONTAP is a popular OBDA tool, ontology-based data access system, and we are using two languages like OWL2, QL, and SQL database. And Proteus, it is also one of the tool in order to develop the. It is an open source tool, and we are developing open source ontology applications by using OBDA system itself, Proteus, and Mastro. Mastro is also relational data sources, and it develops ontology based applications, and we can write a high level queries. R2R ML, so W3C. So these are the two tools we are using for mapping purpose, providing a bridge between the world of relational databases and semantic web technologies. Graph DB. Graph DB is a semantic graph database that supports OBDA. It allows users to organize and store data in graph format, which can make complex relationship between data easier to understand query. And Virtuoso is a high performance universal server that supports a variety of data access, integration, management tasks. It includes support for RDF, resource description framework, and SparkQL, making it suitable backend for OBDA system. So these are the various tools started with 1970 ETL tool, extraction, transformation, loading tool. Then 2000s OBDA system came. 2020 OBDA star. Then queries, mappings, etc. And the techniques. What are the techniques are used to develop ontology based data access applications? Ontology mapping is one of the technique, and semantic querying is one more technique. Query rewriting is one more technique. Reasoning, data integration, data transformation, etc. Techniques of ontology based data access. There are various techniques like wrapper RDF, wrapper XML, wrapper CSV, wrapper RDF, wrapper XML, wrapper CSV, etc. And what are the research challenges of ontology based data access? So complexity of ontology mapping means huge volume of data is there, and you are going to develop ontology based. It takes time and difficult to perform the mapping. That's why it is called a research challenge in ontology. Performance based on the system or server it supports for a huge computing power queries we are using. That's why performance is a matter. Scalability, we are increasing the size of the data, automatically our data center size also increases. Expressiveness versus performance trade-off. So we are checking performance trade-off conditions and expressive. You can check whether that expressive we are using or not. Data consistency and quality. So when we can call it data consistency, 10, 20, 30, 40 continuously it is coming. Next future value also it will come. And the quality of the data. This ontology may take certain assumptions about the data that are not always met, leading to incorrect query results. Evolution of data sources and ontologies. This is also one of the challenge, how it is evolved and what type of version right now it is ongoing. Integration of heterogeneous data. It is a difficult task to integrate multiple data sources, and these are the research challenges of ontology based data access. So data donor, consent from disease specific is melanoma, and data repository, data set A tool, data set 7. How do we develop applications? So I have explained the homework I have given, how to create an ontology of information technology. You need to check ontology, place you need to keep information technology and write down remaining what is information science, what is knowledge, what is domain, what is reasoning, what is relationships, what is concepts, set of concepts, computer science, etc. So, example for how to create an ontology of a computer science like programming, I have explained already. Programming theory, equipment, information system, artificial intelligence. If we see artificial intelligence, what are the subjects are covered? Expert system, machine translation, recognition image, computational linguistics, modeling, reasoning. Then now I am going to demonstrate. Please, all of you open your laptops. So my screen is visible. I am downloading Python software. Now I am going to demonstrate. Shankar sir, please
Okay.
ask them all of you open their system.
So actually, they didn't bring their laptop, sir. So we didn't
They
inform
are
it.
they
So
joined
but
the laboratory now, sir. Where they joined? At least open
they are in the
Google.
classroom, sir. They are in classroom. They are observing your class, sir. On
Okay.
TV screen, they are observing everything, sir. Everything is clear. and visible.
Okay, now I am going to demonstrate, sir.
Okay,
Please,
sir.
which year students, sir, they are?
Second sem, sir. Second sem students. First year
Okay,
only.
see.
First year.
Yeah. My dear students, please see how to install Python within 1 minute. Then I'm going to demonstrate various applications of ontology-based applications. See here, Python software. Go to Python
అరే
software
వినండి వేస్ట్ ఫెలోస్.
and go to
ఒక
welcome
క్లాస్
to
ఎలా ఉండకూడదో మీ క్లాస్
python.org
చూపిస్తే సరిపోతుందేమో.
and download
మినిమం కామన్
Python
సెన్స్ లేదు ఒకటి కూడా.
3.11.4. See here,
మనీ
I'm
పే చేస్తాం
downloading.
రా. ఫ్రీ కాదు
So I'm
అతను.
downloading. It is a
వేరే
26 MB
కంట్రీ నుంచి
file. It is
ఆయన.
already downloaded. Please see here.
వేస్ట్ ఫెలోస్.
This is the software.
ఎవడో
My screen
రన్నింగ్
is
కామెంట్
visible, sir.
చేస్తున్నాడు.
Yeah, my screen is visible.
ఎస్ సార్ ఎస్ సార్
My dear,
విజిబుల్ సార్.
yeah. So double click. If you double click, so it will open and icon will come. There you need to select it. Add path. That's all. Next, like that. It takes 1 minute. So I have already installed the Python software. I'm going to show you now.
ఒక్కడికి వినే ఇంటెన్షనే లేదు. మాకు పిచ్చి పట్టింది అనుకుంటున్నారా ఇంత ఖర్చు పెట్టడానికి?
So once you have installed, go to CMD. See, I have already installed. My screen is visible. Now CLS, clear the screen. And now I am checking the Python version. Python. See which version I have installed? 3.11.4. My screen is visible, sir. So I'm writing. I want to clear the screen. Just
ఎవరో
use import
టీవీ ఆఫ్
OS.
చేస్తారు ఎదవ.
Please write down.
తెలిసిందంటే ఉంటుంది. టీవీ
Enter
ఫ్యాక్షన్.
OS dot system of
సీసీ కెమెరా చూస్తారండి. ఎవడో కావాలని టీవీ
CLS.
రిమోట్ ఆఫ్ చేస్తున్నాడు.
So CLS. So it is cleared. Now if you want to go
మీరు
to
పెద్ద మేధావులంటే
Python can
మీకన్నా
be
మేధావులు
executed
మేము
in two
ఓకేనా?
ways. One is
సీసీటీవీలు అన్ని
ideally and
చూస్తాను
one
నేను
more is
ఎవరైనా ఎగవేసాలు
scripting
వేసారంటే.
way. Now
ఇంకోసారి
suppose you
ఎవరైనా
want to
టీవీ ఆఫ్
quit.
చేస్తూ ఉంటుంది.
Parenthesis begin, parenthesis close.
వేస్ట్
This
ఫెలోస్.
is called
వాడు నిద్రపోతాడు
scripting
వాడు.
way. Here also you can
నిద్రపోవడానికి
write
వచ్చాడేమో కాలేజీకి.
notepad
అందుకే పే
space.
చేస్తున్నాడు లక్షలు
So
లక్షలు.
before that I will explain
వేస్ట్
ideally
ఫెలోస్.
program how
మనీ
to
వాల్యూ తెలుసా
execute.
మీకు?
Type Python.
పేరెంట్స్ ఏమో
Which
లక్షలు లక్షలు
version?
ఖర్చు పెడతారు. మీరేంటంటే
3.11.4.
ఒక్కడి
Now I am
వినే
writing
ఇంట్రెస్టే లేదు.
hash is a comment section.
ఇంత వేస్ట్ ఫెలోస్.
Write a Python program.
మళ్ళీ ఒక్కొక్కరికి
Small
960,
program I will
970,
execute first.
950
Then
ఇలా
I
ఉన్నాయి
will
మార్క్స్.
execute applications. Write a
Waste
Python
fellows.
program
ఆయన
to
క్వశ్చన్స్ అడుగుతాడు ఇప్పుడు.
perform addition of two numbers. Otherwise, all
ఆ
arithmetic
రన్నింగ్
operations.
కామెంట్ ఆపండి.
Perform all arithmetic operations. All arithmetic operations using static input. Using static input. Now I'm taking input variable a equal to 3, input variable b equal to 2, a is equal to a plus b. Okay, and sorry, c is the resultant variable, and you can check what are the variables we got it. A value is 3, b value is 2, and a value is see a value again how much it is getting 5 because 3 plus 2 recent values. Sir, I don't want this data, so you can clear the screen. OS dot system of CLS. So again I'll do it once again for you, easy to understand. So write a Python program. See here, write a Python program to perform all arithmetic operations using static input. So I am declaring a is equal to 3, b is equal to 2, c is equal to a plus b, okay, and d is equal to a minus b, subtraction e is equal to a star b, then f is equal to a division by b, and g is equal to a modulus b. If non engineering student and non technical students also can execute this program. Now check the values of c addition 2 3 plus 2 5. Check the subtraction d 1, and e multiplication, and f and g. So you can use this command also, print c, it will print, and print, okay, print subtraction equal to, like this also you can use d. So here subtraction is equal to 1, So like this, you can perform a static input. Same program, how do I can execute in the scripting way? Please see here, quit, CLS. So now I'm executing scripting way. Notepad space, all arithmetic, all arithmetic. Okay, so I'm giving the file name all arithmetic operations. See here, write a Python program to perform all arithmetic operations using static input. Same program. A is equal to 3, B is equal to C is equal to A plus B, D is equal to A minus B, E is equal to A star B, F is equal to A slash B, and G is equal to A modulus B. So print addition equal to C, print subtraction equal to D, print multiplication equal to E, print division F, print modular division and G. If you want, you can execute this program. After this one, Control S and go to Python space, all arithmetic. So I'm executing. See now, addition equal to 5, subtraction is equal to 1. It is a static input. I have declared 3 and 2. Then multiplication 6, division 1.5, modulo division 1. So I'm creating one more file, notepad space IARE, Institute of Aeronautics Engineering. IARE. Suppose I am giving file name iare.py. So here I am creating a dynamic input. See here, hash, hash is a comment section. Write a Python program to perform all arithmetic operations using dynamic input. Now, this is for understanding. Next, I am going to demonstrate ontology-based applications. A is equal to, I am reading the dynamic input value. Input of A is equal to int of input of, double quotes begin, enter value of A. Then B equal to int of input of enter value of B. Then C is equal to A plus B, D is equal to A minus B, and E is equal to A star B, and F is equal to A division by B, and T is equal to A modulus B. Now print addition equal to output variable is C, print subtraction equal to D, and print multiplication equal to DEF. E, na? Sorry. E is the multiplication output variable. Print division equal to F is the output variable. Print modulo division equal to T. So after typing this program, save Control S. Then go to run command Python space IARE. See here, file name is IARE. Now it is asking, my system is asking enter value of A. 3, enter value of B, 2. Now check the values. Addition is 5, subtraction is 1, multiplication 6, division 1.5, modular division 1. Now I am going to explain our ontology based application. Any doubt? Hello, my dear students. Any doubt?
No,
Now
sir.
I
No,
am
sir.
going. It is clear, sir?
Yes, sir. Yes, sir. It's clear.
Now I am going to develop see, write a Python program to create an
There are
ontology
doubts
for
ఉన్నాయా?
computer science. See, I have given assignment, my dear students.
వచ్చేది
I
డౌట్.
told you how to create, see, how to create an ontology for computer science. Sir, ontology is a relationship between index terms and keywords based on past data, existing data, and future data. And we are developing refined view, okay, and refined view of a formal representation of information about computer science, and we are developing application. Now see here, computer science formal representation, like it consists of concepts like programming, theory, equipment, information system, artificial intelligence. So these are the various terminology. Now I am developing through Python programming. See here, write a Python program to create an ontology for computer science. What I am going to do, I am creating a class. My class name is a ontology, and colon, this is the way we are declaring a class in Python. I am defining init
ఏం
function
చేస్తున్నావు?
like
స్టాండ్ అప్.
you can call it as a
స్టూడెంట్
initialization
స్టాండ్ అప్, యు
purpose.
ఓన్లీ.
So
ఏం చేస్తున్నావు
constructor,
నువ్వు?
here we can call it the constructor,
ఆ?
define init self,
ఏం
it
డిస్కస్
points
చేస్తున్నారు మీ
itself,
ఇద్దరు?
then self dot ontology.
ఎన్నిసార్లు చెప్పాలి నేను?
Okay, so what I am declaring,
అరే ఫస్ట్
definition,
డెస్క్ ఇలా
one
ఉన్నారేంట్రా
function
మీరు?
like add, I am passing the
సిరాన్.
parameter self comma subject comma relationship comma object. So now if subject not in self dot ontology, then it will go to self dot ontology subject, and if again I am writing condition, if relationship not in self dot ontology subject, then again self dot ontology subject and relationship, it will print set self dot ontology of subject relation and dot add of object. Then we have added all these relationships, then finally we are displaying. So for a display and add are the functions of a class. Class is a collection of objects. Class is a collection of methods like functions, add and display. So I'm displaying the whatever I have added for subject relationships in self dot ontology dot items. Then for relationship comma objects in relationship dot items, for object in objects. So print, I'm printing subject relationship object. So I'm creating object for ontology like ONT, it is object of a ontology class and method. So ONT dot add, what I'm adding, computer science has field programming language. Next, ontology ont dot add programming language has type high level language. On type add programming language comma has type lower low level. Finally we are displaying on dot display. Now if you see, I am going to execute now. So what is the file name? Notepad. I am creating a scripting file, ontology CSC. Okay, ontology CSC. See now my file name is ontology creation of computer science. Now this is the file name I have created. See, I have explained already class ontology. So here you can write hash, write a Python program, write a Python program, create ontology, create ontology, ontology for computer science, computer science. Okay, so save the program. I have created class and created object, and I have created and displaying. Now I am going to execute. See here, Python space ontology CSC. My file name is ontology csc.py. Now see, computer science has field programming languages. Programming languages has type high level. Programming languages has type low level. So this is one application of how to develop ontology for computer science engineering. Next application. My screen is visible, sir.
ఎస్ సార్.
Hello, sir.
ఎస్ సార్,
Hello, sir.
విజిబుల్ సార్.
My screen is. Next, write a Python program to create ontology for information technology. Information means processed data, technology means application of science. I'm developing ontology for IT department. What are the subjects and what are the relationships are presented? Same as CSC, class ontology. I'm adding subject relationship, then I'm adding subject and relationship. I'm displaying subject relationship and subject and what are the domain information technology. Like this I'm creating, and I'm creating ontology, adding relationships. Like what are the relationships we are adding? Can anyone see here my screen? So I'm adding the relationships. Information technology has a category programming, and programming uses Python, programming uses Java, information technology. See, this is relationships between the terminology, index terms, and we are developing ontology. Then information technology has category networking. Networking uses TCP/IP. Information technology has a category database management. Data management uses SQL. Like that relations. See how the relationship between all the terms. Database management uses NoSQL, and finally we are displaying the relationships between information technology. Now my screen is visible. Can I execute now?
Yes, sir.
Hello
Yes,
my
sir.
dear friends.
Yes, sir. Yes, sir.
Yeah, for IT students I'm creating notepad space ontology. Okay, ontology it.py. This is the file name I have created. Write a Python program that creates an ontology for a specific area in information technology. So what I have done, I have created a class ontology first, and I'm adding two methods called add and display, and I'm creating the object ONT for ontology, and I'm adding the relationships, and I'm printing that I'm displaying the ontology. Now see here, I'm going to execute Python space. You need to execute like this: ontology it.py. Now see, so information technology has category programming, information technology has category database management, information technology category networking, programming uses Python, programming uses Java, networking uses TCP/IP, database management uses SQL, database management uses NoSQL. Now, can we go for next application?
Yes, sir.
Hello,
Yes, sir.
my dear friend.
Yes,
Write
sir.
a Python program to create an ontology for healthcare and life sciences. See here. So what I am doing, I am importing the packages like import network X as an X. I am importing one package network X. Then create a directed graph. G equal to is a object of the digraph. Nx dot digraph. Create nodes. I am creating the nodes like John, age. John, age 30, type patient, has condition diabetes. And G is the object of the digraph, and add node Mary. Mary age is 25, type is patient, has condition hyper hypertension. Then you could potentially add a relationship between nodes like, okay. So these are the comment section. First we need to create a digraph, then we need to create nodes, then we need to create potentially, then we need to create all nodes their relationships. Now see, so one you could potentially add a relationship between nodes like this: John Mary relationship knows, then print all nodes and their attributes. So I'm using for statement for node, and for node I have created already John and Mary. Attributes in G dot nodes data equal to true. If data is presented, then it will print in the loop. First John it will print, then Mary it will print. Now I'm going to execute now. See, I'm going to execute. My screen is visible, sir. Notepad space
Yes, sir. Visible,
ontology,
sir.
ontology health, ontology dot health. This is the file name I have created. Please see here. And I'm importing a network X package, then creating diagraph,
ఓకే.
creating
మీరు
nodes.
ఇలాగే
You could
ఇలాగే
potentially add
ఉంటే నెక్స్ట్ టైం
relationship
నుంచి
between
మీకు
nodes like this,
ఛాన్సెస్ ఇవ్వరు.
print out all
ఓకేనా?
nodes and their attributes.
ఏంటో కొద్ది కూడా
now
ఇంట్రెస్ట్ లేదు మీకు.
now I'm executing python space
మరి ఇంత దారుణంగా ఉంటే
ontology
ఎలా?
health dot py. Now see the output. John is a node I have created in the diagraph. Age is 30 and type is patient and has condition diabetes. And you can see the Mary age is 25 and type is patient and has condition hypertension. Any doubts? Any doubts, my dear students?
నో డౌట్ సార్. నో డౌట్
Please,
సార్.
sir. So, can I execute one more application?
ఓకే సార్. ఓకే సార్.
Okay. Next, write a Python program to create an ontology for smart cities. What I am doing, I am developing ontology for smart cities in Hyderabad. So I'm creating class called ontology. I'm defining a constructor and I'm using add concept. I'm using add relationship. Then I'm developing the relationship between concept 1, concept 2. Okay, so then I'm displaying about the smart cities. So if relationships in self dot ontology, concept 1 will print. Self dot ontology of concept 1, relationships dot append concept 2 comma relationship. Else self dot ontology concept 1 relationships and concept 2 relationship. So finally, I am displaying the output by using display function, print self ontology. Now I am going to execute this program, very simple program. So notepad space ontology, ontology smart city.py. This is the file name I have created. Okay, write a Python program to create an ontology for smart cities. Okay, and I am displaying and I am executing. Python space ontology smart city.py. Now see smart city description, a city that integrates information and communication technology, that is called ICT, and Internet of Things technology relationship. IoT integrates, ICT integrates, IoT. Okay, so like this, I'm describing information communication technology infrastructure for computing. Okay, so any doubts?
నో సార్. నో
Finance
సార్.
and banking. One more application. Can I execute one more application?
ఎస్ సార్. ఎస్ సార్.
Okay, so finance and banking application. What I have created, I have created a class ontology, and I have created init function. I'm adding concepts like concept and properties, and I'm creating a add function. I'm using relationship concept 1, concept 2, and I'm printing that finance and banking related application. So and so bank and so relationship. So what is the I have created a object called finance ontology. Then I am adding a bank description, a financial institution that accepts deposits and extends loans. Then finance ontology, loan, bank, loan, interest. These three I am adding to the bank system and finding the relationship between bank, loan, extends, loan, interest, charges. That is my aim of the ontology of a finance and banking application. Now I am going to demonstrate. Okay, CLS notepad space ontology finance.py. This is the file name I have created, and I have added all the concepts and terminology of finance and the banking system. Now I am executing Python space ontology finance.py. Now see the output. So which bank? So bank, a financial institution that accepts deposits and extends loans, relationships, loan extends a sum of money that is borrowed and expected to be paid back with interest, relationships and targets the charge for the privilege of borrowing money typically expressed an annual percentage rate. So like this we can execute a number of applications. I am giving homework, you need to execute. Shankar sir, I am giving homework, so let them execute many applications, many projects.
Yes, sir.
Any
Yes,
doubts,
sir.
my dear students?
No, sir.
Please ask me any doubts.
No, no, sir. No, sir.
Okay. So what is the answer for this one? What is an ontology in the context of ODBA? Shankar sir, you can
Okay.
answer
Any
in
student, what is
step.
the answer for that?
What is an ontology in the context of OBDA? Ontology based
Say
data
the
access.
answer.
Sir, what is the answer?
A. So they are saying A
So
or C.
A is a wrong answer, sir.
Okay,
B is a
okay.
high level conceptual model of a domain.
Dakish, acting Dakish.
Next question. In OBDA, mappings are used to. Please answer to
Answer.
this question. What is the answer, sir?
D. D, sir. They
Let
are saying
them.
D.
B. Very good answer. Define how data from the sources can be transformed into instances of the ontology. Next, third question, sir.
What? What is your answer?
What types of data sources can be used
D,
in
sir. They are
OBDA?
saying D.
Yeah. What is the answer?
D.
Yeah, all of the above and more. Very good. Next, fourth question. Which of the following is an advanced topic in OBDA? Yeah,
What
what is
is
the
your
answer?
answer?
So all of the above, scalability, handling incomplete and uncertain data, temporal and spatial data, all of the above. Next, fifth question. In OBDA, why is ontology used as an interface between users and data sources? What is the answer? Correct. Both A and B. Perfect. Perfect. Sixth one, in the context of OBDA, ontology-based data access, what is the role of machine learning? Please tell me the answer.
Sir, some students saying B, sir. Some students
Yeah.
saying D.
Okay. Now see all of the above. Next, seventh question.
Pray waste fellows.
Seventh question. What is a key challenge in handling temporal and spatial data in OBDA? What is the answer? Both A and B. Perfect answer. Extending the ontology languages to handle temporal and spatial constructs and devising efficient query and answering techniques for such data. Eighth question. Which of the following could be a measure to handle scalability in OBDA? What is the
Okay,
answer?
what is your answer? Sir, some students saying D, sir.
Yes, correct answer. All of the above. Next, ninth question. What is the primary function of ontology-based data access? Anyone?
Ah. Sir, some students saying C, sir.
Okay, C. B
B.
is the correct answer. To abstract the database structure into an easy to understand understand format for users. Next, last question. What is the key process in OBDA that allows high-level queries against the ontology to be rewritten or transformed
Sir,
into
they are
equal
saying C,
queries
sir.
over the actual data sources? Query transformation, perfect answer. Okay, so these are the case studies I'm going to share with you. Your coordinators are healthcare and life sciences, supply chain
Hey,
management,
silence.
smart cities, environment monitoring, finance and banking, aerospace and defense. The next projects like the optic project, Bio2 RDF project, linked life data, the semantically interlinked online communities project, the open biological and biomedical ontologies foundry, the DPpedia project, and these are the assignment questions.
రే
I have given
సైలెన్స్,
already assignment questions. You
10
need to
minutes సైలెన్స్
submit
కొనండి.
tomorrow to your coordinator with answers. So all of you, there is a
Silence.
there is a YouTube channel, my dear students. You can type Dr. Asadi, and if you are having mobile or laptop, go to YouTube, type Dr. Asadi, and you can subscribe and listen, and
రే
you can give any comments on that videos. That's all from my side. Thank you, sir, for
సార్
giving
సార్
me
సార్ సార్
opportunity.
1 second సార్ 1 second సార్ could you
Any
please
doubts?
give sir could you please give overall conclusion on this 5 days workshop, sir,
Sir, it is a
and
excellent
suggestions
program. Yes, sir. It is
suggestions
a
to our
excellent
students.
program about it is an excellent program about ontology based data access. We have learned various tools and techniques, advantages and applications. Being a second semester, you need to develop any web application related of ontology for web application, and you can develop ontology for health application. And this is uh, congratulations to IARE. They have done tremendous job for conducting high-level international training program on ontology. It is a special concept, especially in web technologies, and we are creating mappings. We are creating a refined view by using a formal representation of information or refined data, refined view of a formal representation of knowledge between your domain. And that's why ontology is the interface between a user and multiple data sources. You can develop n number of applications. I would like to uh, I would like to give thanks to management, principal, and HODs, deans, and faculty members, my dear students. And this is a wonderful opportunity for me to explore my knowledge in artificial intelligence, that is ontology-based data access. Thanks to Dr. Polaya sir, Dr. Shankar sir, they have conducted wonderful workshop training program, that is the international program, and you have seen practicals, and you need to develop applications in your own domain. So thanks for attending and this 5 day international training program. And if you have a time, you can go to YouTube and type Dr. Asadi Srinivasulu. You will get my channel. Please subscribe, my dear students. Your 60 students are there. I want to see 60 student names in my channel. You can contact anytime. You can ask me any doubt. You can clarify with me. I will do projects for you. Don't worry. Thank you, sir. Shankar, sir. Any doubts?
Sir, 2 minutes, sir, our student giving vote of thanks, sir. 2 minutes, sir.
Yes, sir.
Good morning, all. On behalf of Institute of Aeronautical Engineering, I take this opportunity to propose vote of thanks to those who have directly and indirectly contributed to this workshop on ontology-based data access organized by our institute. At the outset, I thank our chief guest, Dr. Asadi Srinivasulu, sir. We are really enlightened with your knowledge and presence. Thank you, sir, and our head of the department, Purushottam Reddy, sir. Once again, thank you all for cooperating and made this successful.
Sir,
Photo,
Shankar
sir.
sir,
Sir.
Shankar sir, please
Sir.
share these 3 videos. 3 days I have taken, sir. Three
Okay, sir.
videos share to my WhatsApp or email ID, sir. Thank
Okay,
you,
sir.
sir, for giving me opportunity. I am sharing this PPT to you, and I
Okay,
am
sir.
giving assignment for the students. Let
Okay,
them
sir.
solve projects and case studies and assignment questions. Shankar sir,
Okay,
all
sir.
students tomorrow they are submitting assignment through papers. Through
Okay, sir.
papers you need to submit, and you can maintain a file, sir, for international training program that you can show to committees NIRF, NBA, NAC.
Yes, sir.
Okay, sir.
Yes.
Thank you, sir, for giving me this opportunity.
Thank you, sir. Thank you. Shall we wind up, sir?
Yes, sir. Thank you,
Okay,
sir.
sir. ఓకే క్లాస్ సిఆర్ ఎవరు అటెండెన్స్ తీసుకోండి ఇవేనా అటెండెన్స్ తీసుకొని మీ సార్కి ఇచ్చేయాలి ఓకే